Alright guys, I'm going to work through each one of these problems so that you can check it with what you've already done. And then you're able to see if you got it correct or if you didn't and possibly why you didn't. But again, if you don't understand, you can always come see me and I'm here to help. So for the first 4 problems, as you can see, it's just simple 2-digit by 2-digit multiplication. I'm going to do the standard algorithm. However, you have the option to do area model or partial products. So let's get started. We have 32 times 12. So remember, with standard algorithm, you're going to cover up this 1. And so now we're just multiplying 32 times 2. Well, 2 times 2 is 4. And then 2 times 3 is 6. So in our first row, we have 64. Now we're going to scratch out the 2, and when we do that, we have to put our placeholder. So now we're going to multiply 1 times 2, which is 2, and 1 times 3, which is 3. Once we get our partial products, we'll add them together. 4 plus 0 is 4, 6 plus 2 is 8, and bring down your 3. So our answer is 384, which is C. Alright, let's do that again for number 2. So we have 31 times 17. Cover up that 1. We have 7 times 1, which is 7. Then we have 7 times 3, which is 21. So in your first row, you should get 217. Scratch the 7 out since we're done with it. And when you scratch it, you immediately put your placeholder. 1 times 1 is 1. 1 times 3 is 3. Now we can add our partial products. 7 plus 0 is 7, 1 plus 1 is 2, and 2 plus 3 is 5. So our answer is 527, which is D. Alright, number 3, 51 times 16. Cover up that 1. So now I'm doing 6 times 1, which is 6. And then I'm going to do 6 times 5, which is 30. So in our first row, we have 306. Then I get to scratch the 6 out, and when that happens, we got to put a placeholder. 1 times 1 is 1, and then 1 times 5 is 5. So we add these up. 6 plus 0 is 6, 0 plus 1 is 1, and 3 plus 5 is 8. So our answer is 816, which is B. And lastly, number 4. So there's 2 ways you can do this. You can either just do 34 times 7 and then put your 0 back, or you can do the standard algorithm or area model. So 34 times 70, 0 times 4 is 0, 0 times 3 is 0. We're done with the 0, so we scratch it out and we put our placeholder. 7 times 4 is 28. So we have to put our 8, but then add our 2 because we did not multiply 7 times 3 yet. So 7 times 3 is 21, plus 2 more, 22, 23. So now we can add these together. 0, 8, 3, and 2. So our answer is 2,380, which is C. Alright, here's our first word problem. It says Paulette saw 13 new Wii games that she wanted to buy. Each new game costs $24. How much money would she need to buy all of the games? So here, with it being, all, I know that I have to find my total. I know that one game is $24, but it says that there's 13. Well, instead of drawing 13 out, I'm just going to go dot, 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 13. So I know that I have to multiply 24 times 13. So 24 times 13. cover up that 1. 3 times 4 is 12, so put your 2, add your 1. Then we have to do 3 times 2, which is 6, plus 1 more is 7. So in our first column, we have 72. We're done with 3, so we scratch that out, but we also had a regrouping, so we need to scratch this out as well. So now we're ready to put our placeholder and multiply 1 times 4, which is 4, and then 1 times 2, which is 2. And we can add these together. 2 plus 0 is 2, 7 plus 4 is 11, add your 1, and 2 plus 1 is 3. So our answer is 312, which is D. Alright, let's look at number 6. Tyler has 42 sets of baseball cards. Jason has 63 sets of baseball cards.
Miss Email, please contact the front office. Trisha Email.
Sorry about that. It says each set has 38 cards. How many cards does Tyler and Jason have all together? So again, there's some key words in here. First off, with all together and having Tyler and Jason, we know that we're going to have to solve for a total. Now, Tyler has 42 cards, and Jason has 63 sets of cards. Now, I have 42 and 63. And that's going to give me the total amount of cards, sets of cards. However, what are we going to do with this 38? Well, one set has 38 cards. Well, if Tyler has 42 sets, then we would have to multiply 42 times 38. And then Jason has 63 sets, so we would have to multiply 63 times 38. So actually, our tape diagram is going to have to change. So instead of Tyler just having 42 and Jason just having 63, we're going to have to revise our tape diagram so that Tyler now has 42 times 38, and then Jason has 63 times 38. So now when we go to get our total, all of our numbers are included in there. So let's work that out. We have 42 times 38. 8 times 2 is 16. Put your 6, add your 1. 8 times 4 is 32, plus 1 more is 33. We're done with the 8, so we scratch it out and we put our placeholder. We're also done with this regrouping, so we need to scratch this out as well. 3 times 2 is 6, and then 4 times 3 is 12. So we add these up. 6 plus 0 is 6. 6 plus 3 is 9. 2 plus 3 is 5, and bring down your 1. Now this number here is not our final answer. This was 42 times 38, so this represents Tyler's amount. So Tyler is equal to 1,596. We still have to solve for Jason, so I'm going to work Jason up here. So now we have to do 63 times 38. 8 times 3 is 24. Put my 4, add my 2. 8 times 6 is 48, 49, 50. So in my first row, I have 504. I'm done with my 8, so I scratch it out and put a placeholder. I'm also done with this regrouping, so I need to scratch that out. Then I can do 3 times 3, which is 9, and then 3 times 6, which is 18. Now I can add these together. 4 plus 0 is 4. 0 plus 9 is 9. 8 plus 5 is 13. Put your 3, add your 1, and then 1 plus 1 is 2. So again, we just did 63 times 38, which represents Jason. So this is not our correct answer yet either. So under Jason, I'm going to put, and I'm just going to block this off, 2,394. And that's for Jason. Now we just did all this work. But remember, the question says, how many cards does Tyler and Jason have? So we still haven't gotten to our whole yet. So now we have to take Tyler's amount, which is 1,596. And we have to take Jason's amount, which is 2,394. And we have to add these together to get our total. So 6 plus 4 is 10. Put your 0, add your 1. 9 plus 9 is 18, plus 1 more is 19. 5 plus 3 is 8, plus 1 more is 9. And then 2 plus 1 is 3. So our total is 3,990. Now when I look over here, I do not see that. So I need to double check my work. 6 plus 4 is 10, 19, 8, 9, and 3. So let me check my multiplication. So 8 times 2 is 16. 8 times 4 is 32, plus 1 more is 33, so that checks out. Put my placeholder. 3 times 2 is 6. 3 times 4 is 12, so that checks out. 6, 9, 5, and 1. Okay, so this one's correct. Let me check Jason. So 8 times 3 is 24. Put my 2. 8 times 6 is 48. 49, 50, so that's correct. Placeholder. 3 times 3 is 9. And then 3 times 6 is 18. Okay, that checked out. 4, 9, 13. Put my 1 and 2, so that checks out. So it looks like there's no answer here. So instead of having 4,090, we'll change this to a 3, and it'll be 3,990, which is B. So my mistake. All right, number 7. The model below shows which multiplication equation. So I have these 4 different multiplication equations. So you got to think, whenever we set up area model, we were breaking down these numbers. So if I have 20 plus 7, then that means I started off with 27. And then if I'm multiplying my length, times my width, then I have to multiply. And then 50 plus 5 is 55. So before we drew this model, we were starting off with the equation 27 times 55, which is D. All right, let's look at 8. So 8 looks difficult, but it's really not. So with this one, we're going to have an area model. It says Jack wants to solve the problem 42 times 53, which shows how he can solve it. So you'll notice that this is the distributive property which goes with area model. So I'm going to draw a little bitty box down here, and I'm going to break it up into 4. So I know that I need 42, and we can expand 42 into 40 and 2, 40 and 2, times 53, so we can expand 53 into 50 and 3, 50 and 3. So now when I multiply each corner, I'm going to have 40 times 50 plus 50 times 2 plus 3 times 2 plus 40 times 3. And I know these are out of order, but we can check them off. So A, 40 times 50, yes. 40 times 3, yes. 2 times 50, yes. 2 times 3, yes. So A checks out. 40 times 50, yes. 4 times 3, no, I do not have that. 40 times 40 times 5, no, I do not have that. And then here, all we're doing is adding, we're not even multiplying. So this one can't be correct. So our only answer here is A. Alright, number 9. Kayla has 53 times as many Bob Cash as Brian. Brian has 27 Bob Cash. How many Bob Cash do they have combined? So Kayla has 53 times as many Bob Cash as Brian. So remember, times as many means to multiply. Brian has 27 Bob Cash. So how many Bob Cash do they have combined? So this word combined again tells me that I'm solving for my total. And I have two people. I have Kayla and I have Brian. Well, we know Brian has 27. And then we know Kayla has 53 times Brian. So Kayla has 53 times the amount of Brian, which is 27. So first, we're going to have to solve for Kayla because we don't know her. But we want to know what Kayla and Brian are together. So let's solve for Kayla. We have 53 times 27. So 7 times 3 is 21. Add your 2. 7 times 5. 7 times 5 is 35. Plus 2 more is 37. So in our first row, we have 371. We're done with our 7, so we scratch it out, which means we need our placeholder. And we can also scratch out this regrouping. Now we're ready to multiply 2 times 3, which is 6, and 2 times 5, which is 10. So now we can add these partial products together. 1 plus 0 is 1. 6 plus 7 is 13. Put your 3. Add your 1. 3 plus 1 is 4. And then bring down your 1. So here we get 1,431. And be careful because that is an answer choice. However, if you go back to your tape diagram, which is why I have y'all draw it, this equation only represented Kayla. So Kayla is equal to 1,431. But we want the combined. We still have not solved for our whole yet. So now we need to add Kayla and Brian. So 1,431 plus 27. 7 plus 1 is 8. 2 plus 3 is 5. Bring down your 4 and bring down your 1. So now our final answer is 1,458, which is C. So there's going to be some 2- and 3-step word problems on your test tomorrow. You need to draw out your pictures. That's why I drew them out up here, because it helps you understand what the equations you're doing represents. Okay? All right, flip to the back. All right, number 10. There were 42 muffins in each bin. Miss Rogers bought 4 bins of brownies, but ate 8 of them on her way home. How many brownies does Mrs. Rogers have left? So we know we have 42 muffins in each bin. So that means in one bin, there's 42 muffins. But Miss Rogers bought 4 bins. So 2, 3, 4. So 42 42 and 42. But then she ate 8 of them. So let's figure out how many brownies Miss Rogers has altogether. So we have 42 plus 42 plus 42 plus 42, or we could do 42, oops, sorry guys, times 4. Let me see if I can throw something and the light will go off. Yep, there we go. Alright, so 4 times 2 is 8, and 4 times 4 is 16. So right now, Miss Rogers has 168 brownies. But think about what happens when you eat brownies. Do you get more of them? Do they stay the same? Or do they go away? Well, they go away. So that means this 8, we're going to have to subtract. 168 minus 8. So 8 minus 8 is 0. Bring down your 6 and bring down your 1. So how many brownies does Mrs. Rogers have left? She has 160 brownies left. Alright, number 11 we're going to do together, and then 13 and A and B we're going to do together as well.